In the previous module, we learned that people are the most common source of harmful ESD events. Part of the problem is that humans easily acquire an electrostatic charge through triboelectric charging. Simply walking, moving in a chair, or combing our hair is enough to pick up thousands of volts of electrostatic potential. Also, common workplace behaviors such as handling tools and moving papers can lead to the accumulation of static charges and subsequent ESD events. That's where grounding devices come in. Personal grounding devices, such as wrist straps, shoe grounders, and static control clothing, conduct the excess electrons that people and objects acquire through triboelectric charging to the ground. Lightning rods offer a good example of grounding in action. These conductive metal rods protect the people and devices inside a building by channeling the static electricity from lightning strikes through a wire to the ground. The Earth is so large that it can absorb and safely distribute all those incoming electrons without becoming electrically charged itself. A wrist strap works a lot like a lightning rod, except that the static charges are slowly and safely channeled from a person to ground before the sparks start to fly. For example, a person seated at a workstation can accumulate several hundred volts of electrostatic charge simply by lifting their feet or shifting in their chair. If this person were not wearing a wrist strap, the electrostatic charge could easily flow to a sensitive component and damage it. Because of this, wrist straps are usually required when sitting or standing close to your workstation. The wrist strap needs to be worn snugly against bare skin, so that any excess electrons can easily travel from your body to the strap and down the cord to ground. Wrist straps must also have a current-limiting resistor and some form of quick connect-disconnect. The current-limiting resistor protects the person wearing the strap by controlling the flow of current through this intentional path to ground if they happen to touch a source of electricity, such as a power cord with missing insulation. The wrist strap must always be attached securely to a common grounding point at your workstation. A common grounding point ensures that all equipment and components resting on a work surface are at the same electric potential. A difference in potential could exist between a soldering iron connected to one ground and a static dissipative mat connected to another ground. The difference in potential would cause excess electrons to flow from the iron to the component, or vice versa, in a harmful ESD event. Some facilities use a continuous monitoring system to create a constant connection between your wrist strap and a common grounding point. The monitor tells you whether or not your ESD wrist strap is working at any point in time. It can detect both brief interruptions and complete disconnection from the common grounding point. In both cases, the monitor will sound an alarm so that the operator can alert their supervisor to the problem. Not all continuous monitors are the same. Make sure that you familiarize yourself with the rules and procedures required to correctly using the type of monitors installed in your facility. Wrist straps must be tested at regular intervals to make sure they are working properly. For wrist straps, a typical testing procedure involves the following steps. Plug the cord into the wrist strap tester and use the opposite hand to press the test button. Shake and stretch the cord to make sure it doesn't fail. A green light indicates that the wrist strap is working properly. If you receive a red fail light, try rubbing some ESD hand lotion on your wrist or the grounding strap. Then, test the wrist strap again. Wrist straps often need a little moisture to work properly. Alert your supervisor if you continue to receive a red fail light. Testing procedures may vary. Make sure to follow your company's testing guidelines. An operator sits down to begin working at her workstation and needs to wear a wrist strap. Help her by clicking and dragging the wrist strap to the correct place on the operator's wrist. Now that the operator is wearing her wrist strap correctly, she needs to plug it in to begin working. Click and drag the plug to connect her wrist strap. After returning from lunch, an operator tests her wrist strap and gets a fail notification. What should the operator do next? After applying ESD hand lotion to her wrists, the operator tests her wrist strap again and receives a red fail light. What should she do now? Footwear, like ESD shoes and shoe grounders, are also used to channel the static charges on your body to ground. ESD shoes have a built-in conductive path, while shoe grounders rely on a conductive ribbon worn under your foot. The ribbon conducts static electricity from your foot to the floor. ESD shoes and shoe grounders must be worn on both feet to ensure continuous grounding when you are standing at your workstation or walking around. They are designed to work in combination with the special static control flooring in your facility. We will examine static control flooring in the next module. Make sure to follow your company's guidelines for the use of ESD shoes and shoe grounders. There may be rules about when and how to wear, and how to clean and store them. For shoe grounders, a typical testing procedure involves the following steps. Step on the base plate with 1 foot only. Press and hold the test button for 2 to 3 seconds. A green light indicates that the grounder is working properly. Repeat the test with the other foot. If you receive a red fail light, rub some ESD hand lotion on the bottom of your foot or on the contact strip. Grounders often need a little moisture to conduct excess electrons through your sock to ground. Then, repeat the test. Alert your supervisor if you continue to receive a red fail light. Testing procedures may vary. Make sure to follow your company's testing guidelines. The type of clothes that you wear play a part in the accumulation of static electricity. For example, a fabric like polyester is much more likely than cotton to pick up excess electrons from the objects around you. That is why many facilities require the use of static control smocks in addition to other personal grounding like wrist straps and shoe grounders. Static control smocks keep any static charges on your clothes from reaching ESD-sensitive devices in the workplace. The conductive fabric of the smock takes those excess electrons and distributes them evenly across its surface. Then, when the smock touches your skin, these excess electrons are directed to ground through your wrist strap. Be sure to fasten all snaps and buttons so that none of your clothing is left uncovered. You should also make sure the smock's cuffs are touching your skin so that they can safely direct static charges to ground through your wrist strap. An ESD event can quickly and quietly destroy any one of many components on a PCB assembly. So, to minimize the effect of triboelectric charging, the best approach is to minimize handling itself. Even when using personal grounding devices, touch, pick up, put down, and shift assembly components as little as possible. Hold PCBs by the edge or corners. Hold components by the body, not the leads. And never slide a component across a surface. It is very easy to move things around a table absent-mindedly, but when working with ESD-sensitive electronics, mindful consideration of the dangers of ESD can keep your hands steady and components safe. Moving carts, shelving units, and other wheeled equipment across the assembly floor can easily generate static charges that can transfer to the products being transported if they aren't effectively protected. Common mistakes include transporting boxes without their lids and picking up assemblies when not wearing personal grounding. In fact, using an ungrounded cart, even for just a few minutes, can cause latent damage and lead to many unhappy customers. As with wrist straps and foot grounders, All carts and racks should be grounded. For example, ESD carts often use chains or straps that drag on the ground to help dissipate charges through special static control flooring. Other items may have a plug for operators to connect wrist straps to a common point ground, which helps ground both operators and the equipment. An operator needs to safely pick up and move a PCB on their workstation. What is the correct way to handle the PCB? Now the operator has to pick up an electric component needed for their assembly. What is the incorrect way to handle the component? ESD is a big problem in this industry, but there are clearly things you can do to help prevent it from happening. The goal is to electrically ground yourself so that you remain at the same electric potential as the sensitive components that surround you in your workstation. When necessary, be sure to wear a wrist strap connected to a common grounding point, shoe grounders, and a static control smock. However, simply wearing these personnel grounding devices isn't enough. You must remain vigilant and be sure to test your wrist straps and shoe grounders at regular intervals according to your company's procedures. You also need to minimize how often you touch and handle sensitive electronic components. When you handle PCBs and printed circuit board assemblies, hold them by the edges. Hold components by their bodies and not the leads. And never slide components across surfaces. Always transport electronic components on grounded carts and be sure you wear personnel grounding devices when you pick up and move assemblies. However, this isn't the end of the fight against ESD. You will also need to follow facility-wide guidelines designed to protect people and components from its damaging effects. We'll learn more about these procedures in the next module. Let's apply what you've learned in this module.